Okay, so this example, it says find the radius of convergence, and our series is sigma n from 0 to infinity, n plus 1 over 10 to the power n, x minus 4 to the power n. This is a power series. Now, where is the center of this power series? Where is it centered at? At what? 4. So the center is 4. Now this we need because at the end we're going to say, okay, you know, the center is 4, and then you're going to find the radius. So let me just put that over there. Let's do the problem and then see where we come back to it. So for these problems, the first thing you're going to do is you're going to do the ratio test for absolute convergence. And this is where you always start. So that means we take the limit as n goes to infinity, an plus 1 over an, and we take the absolute value of that. So my an is n plus 1 over 10 to the power n, x minus 4 to the power n. So this will be the limit n goes to infinity, absolute value. I need an plus 1 in the numerator. So that'll give me n plus 1 times x minus 4 to the power n plus 1 divided by 10 to the power n plus 1. All of this is my an plus 1. Now, I'm going to divide it by an.
Wouldn't that be plus n plus 2?
Yes, thank you. Because it's n plus 1 plus 1. Thank you so much for pointing that out. N plus 2. There. So that's my an plus 1, right? Because you got n plus 1, you add another one, you get n plus 2. Now, we're dividing it by an, which means that I can just multiply by this an, but I just have to do what? I flip it. So the 10 to the n comes in the numerator. Then the n plus 1, x minus 4 to the power n goes in the denominator. Now I need to simplify it. So to simplify it, I can open this out a little bit more. Limit n goes to infinity, absolute value n plus 2, x minus 4 to the n times x minus 4, then 10 to the n, then over 10 to the n. See, 10 to the n plus 1 is 10 to the n times 10, then n plus 1, x minus 4 to the power n. And now we cancel. Well, we can. So 10 to the n and 10 to the n cancel. X minus 4 to the n, x minus 4 to the n cancel. And nothing else cancels. So I write this as the limit as n goes to infinity. Absolute value, n plus 2 over 10 n plus 1 times x minus 4. Now, we have a rule for absolute values, that the absolute value of A times B is the absolute value of A times the absolute value of B. That enables me to take this x minus 4 out, okay, out of this absolute value over here. So I can write this like this. The limit n goes to infinity, absolute value n plus 2 over 10 n plus 1 times the absolute value of x minus 4. Now the reason I'm doing this is only this first part has n's in it, right? As n changes, only n plus 2 over 10 n plus 1 changes. This x minus 4 doesn't change. There's no n here. right? Yeah, but the x is on the outside.
So whenever there's multiplication of the numerator.
Yes. Pull it out. Now, I know that my n's start at 0, right? And they're also going off to infinity, so this n plus 2 is positive, the n plus 1 is positive, so I don't need absolute value sign, because it's already positive. Is that clear? Yeah? So this is already positive. So I can write it like this. Limit n goes to infinity, n plus 2 over 10 n plus 1 times the absolute value of x minus 4. Now I take the limit of n plus 2 over 10 n plus 1. Okay? And what is that limit going to be? 1 over 10. Why is it 1 over 10? You've got the same degree, right? So the degree of n here is 1, the degree of n here is 1. So you take the leading coefficient of n in the numerator, which is 1, over the leading coefficient of n in the denominator, which is 10. Now, if you want, you can also change your n's to x's and use L'Hopital's rule. You can also divide top and bottom by n and look at that. You can also say when n goes to infinity, this 2 and this 1 don't count, so you get n over 10 n, which gives you 1 over 10. Any way you want to look at it, but you get 1 over 10. Right, over times absolute value x minus 4. So this is doing the ratio test. Okay, and that's the first thing you're going to do. Now you're going to come out and you say, you know what, I need this to be less than 1 for it to converge. So this part you do. This is what you have to do. Is you have to compare this to 1. And you say, okay, if I want this to converge, 1 over 10, absolute value x minus 4 must be less than 1. And now you start doing some work. Now, what work do you do over here? You say, okay, 1 over 10, absolute value x minus 4 is less than 1. So therefore, absolute value x minus 4 is less than, multiply both sides by 10, right? So if you multiply 10 times 1 over 10, you get 1 here. Multiply 1 by 10, you get 10. Right? So I'm just multiplying it by 10. Right? Because I have 1 over 10, absolute value x minus 4 is less than 1. Multiply both sides by 10. From here, I get that the radius of convergence is how much? It's 10. So if they only ask for the radius of convergence, you find it this way. Look at this. I have not opened this up, right? It's just like that. All right, any questions so far? No questions?
Well, how do you know that it's going to be divergent?
If it, now, well, let's go on. We're not done yet. Okay, we just found the radius of convergence. So where was the center of this series? What was the center? 4. And the radius of convergence is 10. So I can go 10 to the right. And if I add 10 over here, what number am I going to get? 14. Or I go 10 to the left, negative 6. So now I know this. On negative 6 to 14, the power series is absolutely convergent. Right. Now, note I didn't say this is the interval of convergence. I'm just saying here it's absolutely convergent. There are 2 points I don't know about. One is negative 6. The other one is what point? 14. Okay? So I have to check those 2 points separately. So my series was sigma. Put it on dual page display so you can see it. So my series was sigma n plus 1 over 10 to the n, x minus 4 to the n. All right. So what I've done so far is I found the radius of convergence. Now I'm going to go on and find the interval of convergence. Now for the interval of convergence, we're going to check the endpoints. So my endpoints, one is x equals negative 6, the other one is x equals 14. Okay? Now here, do not use the ratio or root test. And the reason is, if you plug it in, those are the points that are going to give you 1, so you're not going to get a result. So there's no point in doing that. If you get 1 when you do the ratio test, you're going to get 1 when you do the root test. So don't use those tests. You plug this back into your series. So plug into the power series. So if I plug it in, I'm going to get sigma n plus 1 over 10 to the n from 0 to infinity, negative 6, that's my x, minus 4 to the power n. So this gives me sigma n plus 1 over 10 to the n. Negative 6, negative 4 is negative 10 to the n. Now rewrite negative 10 to the n as n plus 1 over 10 to the n. Then this we write as negative 1 to the n times 10 to the n.
Then that cross goes out.
Then we simplify. So let's simplify 10 to the n and 10 to the n cancel. So here we're going to get sigma n plus 1 times negative 1 to the n. Let me put the negative 1 to the n up front. Negative 1 to the n, 10 to the n. No. Negative 1 to the n times n plus 1. N from 0 to infinity. So what kind of a series is this one now? This is an alternating series. So we can do the alternating series test. It has 2 parts, but the easier one to look at, well, they're both pretty easy, right, to look at? So we can say, okay, condition 1 is Bn plus 1 less than or equal to Bn, not true, because n plus 2 is greater than n plus 1. So that's not true. So the series diverges. At x equals negative 6. So that takes care of that part. And then we do the same thing when x is equal to, yes? Go ahead.
Never mind.
Okay. So this time we plug in 14 and we get sigma n plus 1 over 10 to the n. Then we do 14 minus 4 to the n from 1 to infinity. And here we get sigma n from 1 to infinity, 0 to infinity, n plus 1 over 10 to the n. 14 minus 4 is 10 times 10 to the n. the 10 to the n's cancel, and we get sigma n plus 1, n from 1 to infinity. And this is a positive term series, and I'm going to do the nth term test. So I'm going to take the limit of n plus 1, n goes to infinity, and that gives me infinity. So the series diverges at x equals 2. So all this work needs to be done for me to find the interval of convergence. So in the last step, I say the interval of convergence is -6 to 14. And this will tell me that it's absolutely convergent between -6 and 14. It's divergent at -6. It's divergent at 14. Yes?